In the Got It, we have one more problem, but the graphs are already provided for us. The map is the exact same map, but this time you don't want to spend any more than $30. Okay? So real fast, let's do this. Let's figure out how many tickets you can get. $30 divided by 25 cents is 120 tickets. So your max is 120 tickets. So let's figure out the max of the large. This is like intercepts. So you can say large would be 5L, has to be smaller than or equal to 120. So 5L, and this is using your maximums, if 5L has to be smaller than or equal to 120, L therefore has to be smaller than or equal to 24 when you divide it out. Do the same thing with S. 3 for a small has to be smaller than or equal to 120. Divide, your maximum amount of small has to be less than or equal to 40. So which one of these graphs makes the most sense? Hopefully you will choose B, because when you divide 120 by 5, you get 24, and when you divide 120 by 3, you get 40. So B is your answer. Problem number 3 should look familiar to 2-7, yesterday's lesson. So I'm going to write on here. You might want to use your 2-7 notes to help you if you're a little bit confused. Well, the first thing I need to recognize is I need to get y by itself. Absolutely. So to get y by itself, the first thing I'm going to do is -1 and -1. Please do not put the 1 with the 2 because the 2 is inside the absolute value. So that gives me negative y is less than x plus 2 inside of the absolute value minus 1 on the outside. Again, the 2 and the 1 cannot be put together because the 1 is not inside the absolute value. Now be very careful. You learned a rule in Algebra 1 that they expect you to remember. When you divide by a -1, you have to, I hope you guys are all thinking, flip your inequality sign. So that is going to give you the negative absolute value of x plus 2. Notice I did not distribute it in, I'm leaving it on the outside. And that's going to be plus 1 in the back now. You should stop the video and rewind it if you had trouble getting to this point. So I put the negative out front, and the -1 over the -1 made a positive 1. Yesterday, you learned that you need to find your vertex. Your vertex is opposite of what's in here, so -2, and what you see on the outside, +1. Your slope is what you see on the outside. So your slope is going to be going down 1 over 1 to begin with. Let's find that point. -2, 1 is left 2, up 1. Your slope is down 1 over 1. Down 1 over 1, down 1 over 1. Remember the mistake that a lot of students make? They just connect with a straight line. But remember, this is absolute value, so I have to make it look like a perfect V. So this time I'm going to go down to the left, down to the left, down to the left. It is upside down, which it should be. The reason it should be upside down is because there was a negative out front. Be very careful when you connect. This one will use a broken line because it is not equal to. If you forgot that and you accidentally did a solid line, why don't you guys pause the video, erase your solid line, hopefully you did not use a pen, and write that down. This is a broken line because it is not equal to. Now we have this nice absolute value shape, and it says that it is greater. Because this is greater than, I just have to shade above my absolute value. If it was less than, I'd shade below it. but this one is greater than my absolute value. So I'm just going to highlight all on top of the absolute value as my answer. Got it, number 3. Which of the following is the correct graph of y minus 4 is greater than or equal to the absolute value of 2, greater than or equal to 2 times the absolute value of x minus 1. Whew. Add 4. You got to get y by itself. So really we have y is greater than or equal to 2 times the absolute value of x minus 1 plus 4 on the outside. Your vertex is what I taught you yesterday. Opposite of this, so 1, what you see here, 4. Your slope is what you see on the outside, so 2 over 1. And this one is going to be shaded above because it's greater than. And you will be using a solid line because it is equal to. So which of the following applies that? Over 1 up 4 is right here on this graph. And you should notice it's highlighted above the absolute value, or inside, which means in this case is above the absolute value, and it has a solid line. A has the incorrect vertex. Wrong vertex. Moving on. You can use the transformations maybe if I can spell it. You can use the transformations that we discussed in the previous lessons to help you with your boundary lines and do that quickly. So let's go to problem 4, and that's pretty much what we did in the last problem. What inequality does this represent? First thing to notice is that this is an absolute value problem, right? So let's start with y here. Let's get our symbol. Do you think that since it's shaded above your absolute value, is it going to be greater than or less than? I hope you choose greater than. It is not equal to because it is a broken line. So I have used the idea of above, and I have talked about the idea of a broken line. That tells me that my symbol is greater than. Now what I need to do is come up with my vertex. The vertex in this problem is over 3 down 2. So that means I have to be able to take this information and put it into an equation. Well, that would be x minus 3, remember how it's opposite, and then minus 2. Remember how that one stays the same. The last thing that you usually need is your slope. So let's figure out what our slope is. It looks like it goes up 1 over 1, up 1 over 1. So I would have a positive 1 out here in front. But we usually don't write it if there's nothing else there. So this is the inequality. The got it is the same type of idea. You should notice that it is shaded above. See it? Shaded above. So I'm going to talk about some things. We're going to have y is greater than. It is not a solid line, so I will not use equal to. The vertex is at over negative 4. I'm going to write that down. Vertex is at negative 4 up 3. So when I put my absolute value symbols on here, I'm going to do x plus 4 because it's opposite, plus 3 in the back. But this one is upside down, so I have to count my slope out. It looks like it goes down 1 over 1, down 1 over 1, down 1 over 1 as I come. So that's a negative 1 out front, or just a negative sign. So I'm going to find the one that matches the best, and that would be option D. I have one more example for you, and in this one you should notice is a straight line. So we are no longer talking about absolute values. But when you graph a straight line, what are the most important things to you? I hope you remember that you need to find your intercept and your slope, right? Just like we did in the problems over here. This is in problem 1, I guess. You always need to find m and b. So that's exactly what I'm going to find in this problem down here. M and B. B is always the easiest to find. It's where it crosses the y-axis, in this case at -2. Now we got to be very careful with our slope. Got to find a perfect corner. I see one right there. See how it like hits the axes perfectly? That's up 1 over 2. So when I make my equation, I'm going to do y. Now this is above again. All of them seem to be above, don't they? This one is above, so I use greater than. I will not use equal to because it's not solid. 1/2 x because that's where we put our slope. -2 because that's where we put our y-intercept. Moving on. One more. What inequality does this graph represent? You should notice that if the line was falling, this one is shaded below where the line would be falling. And you should also notice that this is a solid line. So when we do this, we do y is less than or equal to for below and solid. Now we need to find the intercept and we need to find the slope of this straight line. The intercept is at -1. Now we need to go corner to corner. If the intercept's at -1, the next point appears to be down here at the end of the arrow. That is down 3 over 1. So -3 over 1, which reduces to -3. When I make my equation, I do y equals m, so -3x minus 1. Part B says, how can you tell just from looking at this inequality that you need to shade above? Well, you can shade above on this one because it's greater than. And that's how you can tell just by looking. In other words, you don't need that test point that we were talking about. Now it says, can you use the same technique with this equation? Well, this equation you would have to solve for y first. And in this case, since that would require dividing by a negative, like see how there's a negative in front of y? Since this one would require you to divide by a negative, this one you would need to flip the sign. Okay? So be careful if y is ever negative. The last thing I'm going to show you is a helpful chart that students have asked about in the past. Okay, so what I'd like you to do is make a little chart that looks kind of like a tic-tac-toe board. And up here, let's write the words above and below. Okay, and over here, I want you to write the words solid and broken. Now this chart is good to begin with, but you should end up memorize these as we go along. Okay, well we know anything that's above is greater than, right? Anytime you shade above, it's because it's greater than. To be a solid line, it has to be greater than or equal to. You know anything to shade below should be less than. And if you're going to use a solid line, it's because it's less than or equal to. Okay, so I hope that chart helps you. If you want to get ahead, you can always grab the 2-8 homework packet. Hopefully you did that already, or you can just print it offline. Have a great night.